And dividing our complex numbers is definitely the hardest operation we've done with them, with our complex numbers so far. So let's get a little more practice here. Example 4b, dividing complex numbers. Again, I have two problems here, similar to what we saw in example 4a. This first part, I have 7i over 8 plus I, and I have a binomial in the denominator. Keep in mind, anytime I have an imaginary in the denominator, we can get rid of it by multiplying by that complex conjugate. So in this case, I need to multiply by 8 minus I on top and bottom. 7i times 8 is 56i. 7i times negative I is minus 7i squared. And then I have to FOIL the denominator here. So 8 times 8 is 64. Outside is minus 8i. Inside's plus 8i. And then I times negative I squared. So again, the fact that my two binomials here, my complex numbers, are the same thing but opposite signs, make it so right here, my negative 8i and positive 8i cancel out. So on the top, in the numerator, I have 56i minus 7i squared, but negative 7i squared is really positive 7 over 64 negative I squared would be positive 1. Last little bit, I'm just going to rearrange my terms here. 7 plus 56i over 65. And over here, 3 plus 2i over negative 5i. I can get rid of my imaginary in the denominator by multiplying by that complex conjugate. So I'd multiply by 0 plus 5i, or just 5i here, on the top and bottom. And keep in mind, the reason I can do this is because 5i over 5i is really just 1, so I can multiply by 1 and not get into trouble, not break rules. So I'll take this 5i, distribute it over here. 5i times 3 is 15i. 5i times 2i is plus 10i squared. And then in the denominator, negative 5i times positive 5i is negative 25i squared. And we just have a little more simplifying to do. Okay, so I have 15i here. 10i squared is negative 10. And then negative 25i squared is positive 25. Now at this point, everything is divisible by 5. Negative 10, 15, and 25. So divide everything by 5, and that gives me negative 2 plus 3i all over 5.